I'm here today to help you out with the 3 different quadratic equations that exist out there. So we have one parabola on this Desmos screen right here. And notice I have 3 equations entered into Desmos. And that's because this is a triplet of equations of different forms that all are about the same quadratic function. And therefore, it only yields this one parabola. So we're going to take a moment and talk about what are the types of equations and what they tell us. So here is the first one. So this right here is called vertex form. By name alone, you can figure out it's going to tell us the vertex. This one right here is standard form. This one tells us the y-intercept. We'll go through all this together. And this one is factored form, and this one tells us your x-intercepts. So we'll link all these together to these key points that are listed. Okay, so the first one is vertex form. Whoops, I'm still in that one. So for vertex form, we are looking at these 2 positions, the position that is in the quantity grouping with x, and then the value that is outside that grouping. Together, they exist as a coordinate pair that describe the vertex right here. So that point belongs to this point form belongs to that point on the parabola. So notice the -1 came out as is. That one we can always lift it right out of the equation. But notice it's a +3. But in the equation, it looks like a -3. And that's because this vertex formula is always x subtract a number. And so that has to be an x subtract a +3. Because if it was x subtract -3, it'd become x plus 3, right? Which is different than what's listed here. So always remember in this type of formula, which is common in some of our function equations, as you see more of them, that this is x subtract a number. And so that's actually x subtract +3. So it does involve a knowledge of the origins of the formula. And for now, I think you're safe enough to just do a sign change for what is here. Okay, so that's why it's 3, -1 for the vertex. Over here, in the standard form, the last position is the only thing giving us information, and that is telling us the y-intercept, okay? So if x is 0, because if you are a point on the y-axis, your x is 0. So if we make x 0 and x 0, these 2 terms disappear, and we're left with only 8, y equaling 8. And so standard form gives you your y-intercept. So that's why standard form is useful. The last one is vertex form. And that is where we the last one is factored form, and that's where we take a look at these factors, right? It's this trinomial factored, that's where the factored form comes from. And we notice that these give us x-intercepts. So here's one x-intercept, and there is the other. Now notice these do come with a sign flip, but I really want to caution you to not just go with a sign flip and not think about why that's true. Okay, so if we use the zero product property and we say if we're looking for x-intercepts, that's when the y value is 0 so that we can be points on the x-axis, then we're saying this quantity, or maybe both, but one or the other has to be 0 if when they multiply we get it equals 0. And so what you do is you just take a moment and you take each factor and set them separately equal to 0 and find out what would that x have to be if all that quantity was 0. And then you use your linear algebra skills to undo in order to isolate the variables. So that's why we get x as a +4. Now this might seem like extra work, more than necessary given the level of these factors, but the moment a coefficient shows up, you're going to want to remember that you've got these linear solving skills to help you out. So just as a quick recap, this one is vertex form. It tells you the vertex right there. This one is standard form. Standard form tells you the y-intercept. And this one is factored form, and it tells you the x-intercepts.